always been fascinated with electronics and robotics at an early age and have been tinkering with them for quite some time. In this video, I would like to document and share my custom drone build as I dive into the world of drones. To create my drone, I started with measuring and cutting basswood and square poplar dowel to desired length. These are locally sourced materials at nearby hardware and craft stores, such as Lowe's and Hobby Lobby. I then put them together using wood glue. I use weights and boards to apply pressure on them as the glue needs to harden overnight. I then measure the lengths to make sure they are equal. I 3D printed parts which will serve as ventilation and brackets to hold some of the electronic components. Three-D printing normally takes several hours or days depending on the size and resolution when printing. You can never rely on glue on shaking parts. I added self-tapping screws on the frame to reinforce it. Then drilled holes for the motor mounts. The walls are then glued to the sides as well as the 3D printed vent. For the vent, I use epoxy for plastics. I then applied pressure on the frame and cured it overnight. I cut another basswood which will serve as a top cover. I then drilled holes on it and also on the frame, making sure they're all aligned. Inserts are then mounted and pressed. Now to test the alignment. I also drilled holes on the bottom side of the frame for the battery housing. I then added threaded inserts on the 4 holes. "3D printed motor mounts are then installed. I use a lock nut to prevent the motor from coming off, as it will be subjected to vibration. Holes are then drilled on the sides for motor and power cables. There are several electronics involved, and we are going to mount them one at a time. First are the motors. They are screwed on the motor mount. The wires are then routed through the holes. Next is the electronic speed controller and its cable. After mounting the speed controller, the motor wires are soldered onto it. I always cable tie wires to make my builds neat and easier to troubleshoot later on. So this is what it looks like when I mounted the motors and the EC and did the routing of cables as well. So next step is to mount the autopilot like this. It doesn't have to be exactly at the center, but it is recommended. Before that, we need to mount dampeners. This will prevent vibrations going into autopilot. The EEC cable is then plugged between the speed controller and the autopilot. Make sure to refer to Arducopter website for motor wiring diagram. power module distributes power to both speed controller and autopilot. After mounting it, plug one side to speed controller and another connector to autopilot. I then added an extension cable so it could reach the outside battery. This involves soldering and shrink tubing. Push-button switch and GPS are mounted on the same bracket. I mount the switch first, followed by GPS. GPS cables are then plugged in to autopilot, and so is the switch. Buzzer is then plugged and mounted. Any type of RC radio can be used. I use Turnigy, a cheaper alternative. I then plug the connector on the autopilot's RC in. I mounted a simple L-shaped bracket to serve as an antenna mount. I just realized I couldn't plug into the pixel, so let's Dremel it. I cut a slot for the RC antenna and temporarily close the top cover. I then taped the RC antenna on the L bracket. For the battery housing, I will be using carbon fiber. I have no prior experience with carbon fiber, so I'm learning as I go. I use plaster of Paris as a mold to form the shape of the housing. So this is the battery housing. After cleaning it up, I drilled 4 holes and then 2 slots on the sides for the battery cables. It's not pretty, but it's functional. I still need to learn a lot when it comes to carbon fiber. First is to route the cables through the housing. Since it has a play, I need to insert something inside to prevent it from moving. I use cut-out foam board to fill the gap. I then screw the battery housing on the frame. To load firmware and configure the autopilot, we need to download Mission Planner first on our PC. Mission Planner can be downloaded from ArduPilot website. After downloading, power up drone by plugging battery. Unplug US cable from autopilot to PC. After launching Mission Planner, go to Setup tab and install firmware by choosing Copter as seen on the screen. Installation may take a few minutes. After firmware installation, power cycle drone and connect Mission Planner by choosing the right COM port and baud rate, and then choose Setup tab again. Choose frame type and click on X-frame. Next, choose accelerometer calibration. So for us to calibrate accelerometer, we'll have to follow the instructions. This is basically turning the drone on all sides so let the drone know its orientation. Just follow the steps as it directs you to which side to point to ground. Then choose compass calibration. It's a bit tricky with cable, but it's necessary. So for compass calibration, I'm facing north right now. Start calibration. I rotate the quadcopter twice. Then I turn to my left, facing west, and then rotate the quadcopter sideways. And then repeat the process until the calibration is successful. This is awkward. Woohoo! I made it. So basically we're just trying to point the 6 sides of the compass towards north. That's why we are rotating it on all sides, facing north. Go to radio calibration and press calibrate. This will capture the limits of your radio sticks. For flight modes, I choose stabilize, alt hold, and loiter for the first 3, and the rest are RTL. Return to launch. After removing the USB cable from the autopilot, find an open field and test flight. I'm still sweating and I'm still feeling the adrenaline rush. I saw something broke mid-flight. It could be one of the props. I noticed that the front right, the tip of the prop came off, and there's another broken prop on the rear left. It could have been from the crash itself, but mid-flight I suspected that is the front right. I couldn't find anything else. I just heard a weird sound and suddenly it lost altitude, and I was able to lower down the thrust and it bounced on the grass and it turned upside down, and then I was able to turn it off. It was scary because I have my right hand working on the controls and my other hand on the camera, but I wasn't able to capture it because just after I turned it off to move to another perspective, that's when the prop broke off. So after several crashes and broken props, I finally figured it out. I initially suspected that it was the electronics, the motors, the props. I even suspected the arms warping at high speed. I tested it by strapping the drone on a weight and running it at full speed, but somehow I couldn't replicate the props from breaking. So the issue somehow only persists mid-air. The arms tends to resonate at high speed, causing a violent vibration on the props, eventually breaking it. So what I did was add in an angular aluminum, and from there it fixed the problem. So let's go back outside and test it. In addition to the angular aluminums on the arm, I also cut some portion of the top cover to add some aesthetics. And now for the second flight.
far so good. The frame held up, and I'm gonna use this frame for later on experiments in the drone.
Everything went well except when I returned to launch and tried to land on a small platform. I missed the target and scratched the props, but not broken. On the next video, I will try to determine the flight time of this drone. Thank you guys for watching, and feel free to like and subscribe.
Almost.